You're cruising down the highway, windows down, music blasting, and suddenly you realize something wild. You haven't stopped for fuel in months. Not because you're driving some fancy electric car that needs to plug in every night. No, this is different. Your car is literally pulling energy from thin air. Sounds like something straight out of a sci-fi movie, right? Well, hold on to your seats because we're about to dive into one of the most controversial and fascinating claims in modern engineering. There's this inventor from Zimbabwe, goes by the name Maxwell Chikumbutso, and he dropped a bombshell on the world. He says he's cracked the code. Built actual working vehicles that feed off radio waves floating all around us. Yeah, you heard that right. The same invisible signals carrying your favorite songs, your phone calls, your Netflix streams. He claims they can push a 2-ton vehicle down the road. Now, before you start selling your gas guzzler, let me tell you what the physics professors are saying. They're basically laughing this guy out of the room. According to them, this breaks one of the most sacred rules in science. You can't create energy from nothing. Energy in equals energy out, period. But here's where things get interesting. What if we could actually try this ourselves? Not some miracle machine that defies the universe, but something real, something tangible that at least captures the spirit of this wild idea? Today, we're going on a journey. We're going to explore how you could theoretically transform an ordinary car into something that seems to run on pure air. And I'm going to show you not one, but 2 different ways to approach this mind-bending project. But let me be crystal clear here, we're not promising perpetual motion or free energy. This is about pushing boundaries, experimenting with what's possible, and maybe, just maybe, creating something that makes people stop and stare. Before we get our hands dirty, we need to set some ground rules. Working with high-voltage electricity and messing with cars isn't child's play. One wrong move and you could seriously hurt yourself or worse. So if you're thinking about actually trying this, you better know what you're doing. This isn't some weekend craft project you do with the kids. This is advanced stuff that requires real knowledge and respect for the dangers involved. So what exactly are we attempting here? We're not trying to break physics or discover some secret the energy companies don't want you to know about. Radio waves do carry energy, that's a fact. But it's such a tiny amount, it's like trying to fill a swimming pool with an eyedropper. The real challenge, the thing that makes this project so fascinating, is figuring out how to capture and concentrate that whisper of power into something useful. Our goal? Create a vehicle that can actually move, even if it's just crawling a few yards, powered by the electromagnetic soup we're all swimming in every day. Let's talk about the first approach, catching radio waves like a butterfly net catches butterflies. This is the most direct interpretation of what our Zimbabwean inventor claims to have done. Imagine your car as a giant receiver, constantly sucking in every radio signal it can find. AM radio from that oldie station, FM from the pop channels, cell phone towers pinging away, Wi-Fi routers broadcasting from every house on the block. All of these are potential fuel sources. To pull this off, you'd need to start with the right kind of antenna. Not just any old car antenna either. You need something with a huge appetite for frequencies, what the tech heads call a wideband antenna. Picture something like a disc cone design, or maybe one of those logarithmic periodic antennas that look like a TV antenna on steroids. This is your energy net, and the wider you cast it, the more you might catch. But catching the waves is just the beginning. Those radio signals are alternating current, they wiggle back and forth. Your car needs steady, direct current to do anything useful. So you need a converter, but not just any converter. This is where things get really technical. You need what's called a voltage multiplier circuit, fancy electronics that can take those incredibly weak radio signals and squeeze every drop of usable electricity from them. There are specialized chips designed exactly for this purpose, tiny marvels of engineering that can work with power levels so low, most equipment can't even measure them. Here's the reality check though. Even with the best equipment money can buy, you're looking at harvesting maybe a few milliwatts of power. That's thousands of a watt. Your phone charger uses about 5 watts. A single headlight might use 50 watts. And moving a car? That takes thousands of watts. So how do we bridge this massive gap? The answer is patience and storage. You need to think of this system like a rain barrel collecting drops during a drought. Every tiny bit of harvested energy gets stored away, building up over time. For this, you'd use supercapacitors, these amazing devices that can store and release electricity incredibly fast. Unlike regular batteries, they don't wear out from constant charging and discharging. You'd connect banks of these capacitors to your harvesting circuit and just wait. Hours, days, maybe even weeks, slowly accumulating energy drop by precious drop. Once you've built up enough charge, you need to unleash it all at once. This requires a sophisticated power management system that monitors your energy reserves like a hawk. When the capacitors hit their target voltage, the system springs into action, routing that stored power through a boost converter that cranks up the voltage to something an electric motor can actually use. We're talking about jumping from maybe 12 volts to 96 volts or higher. Speaking of motors, you can't run this setup with a regular gas engine. You need to gut the car and install an electric motor. The old-school DC series wound motors are perfect for this. They're simple, tough, and don't need complicated control systems. Hook that motor up to the car's transmission, add a motor controller to regulate speed, wire in a throttle pedal borrowed from an electric bike, and theoretically, you've got yourself a car that runs on radio waves. But let's be honest about what this would actually look like in practice. After charging for an entire day in a radio-rich environment, you might have enough juice to roll forward a couple hundred feet. Then you're done, back to waiting. It's not exactly practical transportation, but as a demonstration, as a conversation starter, it would blow people's minds. Now, let me share the second approach, and this one's got way more potential. Instead of trying to harvest ambient energy like a scavenger, what if we became hunters? What if we built a system that actively beams power to the car? This isn't free energy anymore, it's wireless electricity transmission, something Nikola Tesla was obsessing over more than a century ago. The concept is beautifully simple. You set up a powerful microwave transmitter on the ground, like a lighthouse but for energy instead of light. This transmitter would use a parabolic dish to focus microwave radiation into a tight beam. Think about how a magnifying glass focuses sunlight to burn paper, same principle, different energy. The transmitter would need serious power, probably running off a generator or hefty battery bank. This isn't creating energy from nothing. It's just moving the plug from the wall to a wireless connection. On the car, you'd install something called a rectenna, a combination of antenna and rectifiers specifically designed to catch microwave energy and convert it straight to DC power. Picture an array of tiny antennas covering the car's roof, each one grabbing a piece of that microwave beam and turning it into electricity. When everything's aligned properly, you could generate real, usable power, not milliwatts, but actual watts or even kilowatts. You've got two options for using this power. The simple approach is direct drive. The microwave beam powers the car in real time. As long as you stay in the beam, you've got power. Step outside it and you stop dead. It's like those bumper cars at the carnival that only work when they're touching the electric ceiling. The smarter approach is to use the microwave beam as a wireless charging station. The car would have a small battery pack that the beam constantly tops off. This way, you could drive out of the beam's range for short trips, then come back to recharge. It's like having an invisible extension cord that follows you around, at least within a certain area. The biggest engineering headache with this method is tracking. How do you keep that microwave beam locked onto a moving car? You'd need to get creative here. Maybe the car broadcasts a beacon signal, like a GPS tracker in reverse. The ground station would use this signal to aim its dish, constantly adjusting to keep the beam on target. It's complicated, sure, but it's the same technology we use to track satellites in space. If we can beam data to a probe near Jupiter, we can probably manage a car in a parking lot. Now, I need to hammer home the safety issues with method 2. We're talking about a focused beam of microwave radiation powerful enough to run a car. This isn't something you mess around with. That beam could cook anything that gets in its way, birds, pets, people. The whole experiment would need to happen in a completely controlled environment, far from anything living. This is deadly serious stuff. Comparing these two methods is like comparing a paper airplane to a jet fighter. Method 1, the ambient harvesting approach, is a beautiful demonstration of a principle but completely impractical for actual transportation. It's perfect for understanding the concept, maybe building a tiny model that lights up an LED. Method 2, the beamed power approach, is legitimate engineering. It's been done with drones and small robots. Scaling it to a car is challenging but not impossible. You're not violating physics, you're just being creative with how you deliver electricity. If you're seriously considering tackling a project like this, where do you even start? First off, forget about the RF stuff initially. Start by converting a car to electric. Find something small and light, maybe an old compact car that's seen better days. Rip out everything related to gasoline engine, fuel tank, exhaust, the works. Install your electric motor, get it connected to the wheels, mount your batteries or capacitors, wire up the control systems. Get the car running on regular electric power first. Only then should you even think about adding the wireless power systems. The skills you'll need for this are no joke. We're talking serious electronics knowledge, not just following YouTube tutorials, but actually understanding circuit design, being comfortable with an oscilloscope, knowing how to read and modify schematics. You'll need mechanical skills too, welding, fabrication, automotive systems. For the tracking system in Method 2, add computer programming to the list. And you'll need deep pockets because the components aren't cheap. High-capacity supercapacitors, specialized RF harvesting chips, microwave equipment, it adds up fast. Let's circle back to our friend Maxwell Chikumbutso. Is he for real? Without independent scientists validating his work, we just don't know. The laws of thermodynamics aren't suggestions, they're the most tested, most reliable rules we have for how the universe works. Extraordinary claims need extraordinary evidence, and so far, that evidence hasn't materialized. Maybe he's using one of the methods we've discussed but keeping the details secret. Maybe there's a hidden power source. Or maybe, just maybe, he's stumbled onto something genuinely new. The mystery is part of what makes this whole thing so captivating. But here's the beautiful thing, you don't need to solve that mystery to learn something amazing. Building a project like this, even if it barely works, teaches you about energy harvesting, wireless power transmission, electric vehicle conversion, and pushes your engineering skills to their limits. You're not chasing fairy tales, you're exploring the edges of what's possible with today's technology. You're joining a tradition of inventors and tinkerers who asked, what if? And then actually tried to find out. The future of transportation probably isn't RF-powered cars. It's more likely to be better batteries, hydrogen fuel cells, or something we haven't invented yet. But the spirit of experimentation, the willingness to try something that sounds crazy, that's what drives progress. Every breakthrough started with someone ignoring the people who said it couldn't be done. So where does this leave you? If you're intrigued, start small. Build a tiny RF harvester that can light up a single LED from across the room. Once you've got that working, try powering a small toy car. Learn the principles, understand the challenges, respect the limitations. If you're brave enough and skilled enough to attempt the full-scale version, document everything. Share your failures and successes. Be part of the conversation about what's possible. Remember, this isn't about overthrowing physics or discovering free energy. It's about pushing boundaries, learning by doing, and maybe creating something that makes people stop and think. Whether you're Team Ambient Harvesting or Team Microwave Beam, the journey is what matters. So grab your multimeter, fire up that soldering iron, and start experimenting. Who knows? You might not revolutionize transportation, but you'll definitely learn something incredible along the way. And hey, if you found this deep dive into the world of RF-powered vehicles fascinating, you know what to do. Smash that like button, subscribe for more mind-bending engineering content, and drop a comment below. Tell me, which method would you try first? Are you Team Patience with ambient harvesting, or Team Power with microwave beaming? Let's keep this conversation going because the best ideas come from people brave enough to question everything and crazy enough to actually try. Until next time, keep questioning, keep building, and most importantly, keep that curiosity alive. Peace out.